So a number of practice problems were done where we looked at where lines intersect a horizontal or vertical axis or horizontal or vertical line. Now we're going to take a look at the case where we have two non-vertical or horizontal lines and we want to see where they intersect. Now, if your linear equations are written in a nice form like this, y equals 2x plus 3 and y equals negative x minus 6, all we need to do is either set the y values should be equal to each other or set the x values should be equal to each other. It is very convenient in this form to just set the y values should be equal to each other. So that's what we're going to do. So we're going to say 2x plus 3 is equal to negative x minus 6. What essentially we're doing here is we're assuming that we already know that y values are equal to each other, and we're solving for the x value at that intersect point. Now, if we look at our graph, we see that the dash marks in the x-axis and on the y-axis are both half steps, right? So it's negative half, negative 1, negative 1/2, and then negative 2, and so forth. So I can see from the graph that at x equals negative 3 and y equals negative 3, we have our lines intersect. So we're going to see if we match this, right? So I have 2x plus 3 is equal to negative x minus 6. I move all my x values to one side and all my non-x values to the other side. So then I get, let's see, we'll add x to both sides to get 2x plus x is 3x, and then we'll subtract 3 from both sides. So we get negative 6 minus 3 is negative 9. All right, so then I got 3x equals negative 9, and then divide by 3 on both sides to get x equals negative 3. Now, once you know what the x value is, you need to figure out what the y value is, right? And you can plug this equation into either y equals 2x plus 3 or y equals negative x minus 6. Both equations will give you the same answer if you did this correctly, because that's the definition of when lines intersect. Right? So I'll choose this one first, and then we can use the second one to check our answer. So you plug in x equals negative 3, you get 2 times negative 3 plus 3. So 2 times negative 3 is negative 6 plus 3. Negative 6 plus 3 is negative 3. So y is equal to negative 3. We're going to double check to make sure that's true for this equation as well. So then we get y is equal to negative 3, so positive 3, minus 6. So 3 minus 6 is negative 3. So they do check out, which is good. Right? So it's a good, if you have time, it's always good to double check that the point lies on both equations. And so the point of intersect is x equals negative 3 and y equals negative 3. All right, let's check another problem. So I have y equals x plus 2 and y equals 3x minus 4. So I'll match the y values again, or equate them. I got x plus 2 is equal to 3x minus 4, and I solve for x. So I can subtract x on both sides, and I can add 4 on both sides. So 4 plus 2 is 6. 3x minus x is 2x. And now I can just divide by 2 on both sides, get x equals 3. So looking at the graph right here, we see at x equals 3, I do have an intersect. And again, we're going to plug in, just like we did on the previous problem, x equals 3 to see what y would be for either of these equations. So you plug in x equals 3, let's see what I do for this one. 3 plus 2 is 5. And so if I look at the graph, yes, at y equals 5, x equals 3 is the intersect between these two lines. We could double check with this equation here. So I got 3 times x, or 3 times 3 minus 4. So 3 times 3 is 9. 9 minus 4 is 5. So my point of intersect is x equals 3, y equals 5.